Okay, gents, we're now going to start global maximum and minimum. Now, in a previous lesson, I have spoken to you guys about relative maximum and minimum. Now, the key part is you need to be able to define the difference between a global and a relative maximum and a global and relative minimum. In fact, you can find a maximum turning point, but it not be the global maximum turning point and only be the relative maximum. In a future lesson, we're going to focus on applications of maximisation and minimisation, and this will make sense a little bit more. I'm just going to read this paragraph here. It says, Australia has many high mountain peaks, each of which is a local or relative maximum, because each is the highest point relative to other peaks in the immediate area or locality. Mount Kosciuszko is the highest of these, but is still not a global or absolute maximum because there are higher peaks on other continents of the globe. In fact, Mount Everest in Asia is the global maximum over the world. Now, think of the world as the domain. So if you're being given the domain, then within that domain of the world, then Mount Everest is the tallest mountain. Now, there could be other planets with taller mountains. So if they become a part of the domain, well, then Mount Everest mightn't be. So you have to look at the domain and state whether it's a maximum or minimum. I can draw a quick diagram here. Okay, now let's say that is just a quick diagram there. You've got a maximum here, right there. Okay, but the actual maximum would be there, because that point is higher than the other point. So yes, over here, okay, is a maximum, but that's a local maximum or a relative, whilst this peak here is the global maximum. So very important if you can clearly define the global and relative maximum or minimum. Okay, if I get my little laser going, down here is the global minimum. Here it goes to a minimum, but it's not the global because this one is a lower point given that graph. I'll get a new slide up. Alright, gents, now here is a diagram, and we're going to look further into what it means to have a global maximum or global minimum and relative maximum, relative minimum. So the question is, throughout this diagram here, what is the global maximum? Okay, well, the global maximum would be D, because throughout that graph, that is where it's at its highest point, its maximized point. Yes, granted that B gives a maximum point, but that's a relative maximum or a local maximum. Okay, so it's very important you get the difference there. When we do questions next lesson about maximization and minimization and the applications of, you need to say whether this is a relative or global maximum. Okay, now let's start talking about minimums. Okay, and I'll do that in green. So, you can see down here where the A's, it's the values there minimize out and they approach that dotted line there. But over here in C, you got another minimum point there. But A and C are both relative or local minima, whilst if you look where E is, but not exactly E, but where that arrow is, okay, that will be where the minimization occurs. Now it keeps on going for infinity, so it actually doesn't have a global minimum because that keeps on going, so there's no set area there. If you change the domain, well, then you may. Okay, so you got a global maximum at D, a relative local maximum at B, you got a relative and local minimum at A and C, and the global minimum, well, we don't know because it just keeps on going. It's never ending. Okay, I'm actually not going to guide you through this diagram and show you exactly where the global maximization and minimization is and where the relative maximum and minimum is. So I'm going to now allow you the time, so just pause this video now, and once I finish talking, and I want you to go through and find where the maximum and minimums are, and then state whether they're global or relative. Okay, I quite like this step-by-step bit of guidance here. So if you're testing for a global maximum or minimum, you have to examine and compare Firstly, the turning points. So see if they are maximum or minimum turning points. Then you have to go through your second point is see boundaries of the domain, because you've got to look at, given the domain and the turning points, where does the global maximum or minimum occur. Alright, so it could be at the maximum turning point, the global maximum could be that, or it could be at the ends of the domain, because the function could continue to increase, continue to get higher. Okay, the global minimum, well, you look at your minimum turning points, then you also look at the ends of the graph and see if it continues to decrease or get lower. Alright, you've also got to take into consideration the discontinuities of f-x. That is, well, you want to pick up the sharp corners or discontinuities, e.g. if I draw a quick graph which looks like this. Hang on, I'll just get this all done. Alright, that there is is a sharp corner, and then what it's also talking about, the main thing that you'll cop is this here with an open circle. Alright, what the open circle means, it gets ridiculously close but doesn't actually touch. Okay, so very important, that stuff there. I'll go to the next slide. Now I quite like this worked example here. It says find the global maximum and minimum of the function f of x there, in giving the domain a half, or x is between a half and 5. So how do you find that? Well, you cannot just do that by looking at it. You will have to graph this. Now, emphasizing when we sketch any curve, we find the turning points, we label the turning points, we label the points of inflection, we label the x and y intercepts. Okay, and you're going to have to label the endpoints in this case, and in fact I'm going to show you what the diagram will look like now. Okay, so there's the diagram there. So the question was to find the global maximum and minimum of the function. So let me just get an appropriate color. I'll choose red. Lovely choice. So you can see here at the point 1, 0, you have a maximum turning point. Here at 3, -4, you have a minimum turning point. So we've looked at the turning points there. Then we have to look at the boundaries of the domain. So you can see all the way up here, there's a boundary there, and there is a boundary here. Now there's no sharp corners or discontinuities. So what is the global maximum? Well, it's not the maximum turning point at 1, 0 there. It's not, because the end point is 5, 6, 16, so it's a whole lot higher. So your global maximum is in fact, your global maximum is there. Okay, whilst your global minimum in fact will be that minimum turning point. So given the domain, there's your global maximum and your global minimum, and 1, 0 would be a relative maximum, and a half, -7/8 would be a relative minimum, but your global minimum is 394 and your global maximum is 5, 16, where those arrows are. Hope this makes sense. Please ask me any questions in class.